Hello friends. Today we will study the automatic warning system, commonly known as AWS. This is one of the classic train protection systems used in Anglo-Saxon railways, especially in the United Kingdom. AWS represents an important step in evolution of the in-cab signaling and train safety systems. AWS stands for Automatic Warning System. It is a train-borne warning system designed to alert the driver about the condition of signal ahead. Unlike modern ATP systems, AWS does not enforce speed continuously. Instead, it relies on driver acknowledgement, which is why it is classified mainly as a warning system. Need for train protection systems. In early railways, safety depended heavily on the driver observing trackside signals. As train speeds and traffic density increased, this approach became risky. One major safety issue was SPAD, signal past at danger. This created the need for systems that could warn or intervene automatically. Limitations of mechanical systems. Initially, mechanical train protection systems were used. However, these systems suffered from serious drawbacks. High wear and tear due to friction. Frequent failures in bad weather like snow and strong winds. High maintenance requirements. Because of these issues, mechanical systems were found to be unreliable for long-term safety. Search for improved solutions. Railway engineers then explored many alternative ideas. Some systems were innovative but failed during trials. Others never progressed beyond the concept stage. What the railways needed was a system that was simple, reliable, and fail-safe. Historical background of AWS. In 1930, Alfred Ernst developed the concept of using magnetic induction for train warning. This concept was later improved by Alfred Ernst Hood. A major turning point became after the Harrow and Wheelstone accident in 1952, one of the worst railway disasters in the United Kingdom. This accident accelerated the demand for an effective warning system. Adoption of AWS. Following extensive evaluation of various systems, British authorities selected AWS in 1956. AWS was officially adopted and implemented across British railways. This marked the beginning of nationwide in-cab warning protection in the UK. AWS Basic System Description. Let us understand how AWS works. The system consists of trackside equipment, onboard train equipment. The principle used is magnetic induction, which ensures high reliability with minimal moving parts. Trackside beacon arrangement. At the track, AWS uses two components: a permanent magnet and electromagnet placed next to it. The behavior of the electromagnet depends on the signal aspect ahead, which enables fail-safe operation. Fail-safe principle in AWS. AWS follows a strict fail-safe design. If power fails, the electromagnet becomes inactive. The permanent magnet still triggers a warning. This ensures that unsafe conditions always result in a warning, never silence. AWS operation. Warning aspects. When the signal shows a red, yellow or double yellow, the electromagnet is not energized. The permanent magnet activates the onboard system. An audible warning sounds in the driver's cab. This alerts the driver to a potentially dangerous situation ahead. Driver acknowledgement. After the warning sounds, the driver must acknowledge it. Initially within 1 second, later standardized to 4 seconds. If the driver fails to acknowledge, the system automatically applies the emergency brake. Driver responsibility after acknowledgement. Once the driver acknowledges the warning, control of train remains manual. The driver brakes according to the signal aspect ahead. AWS does not automatically control speed, which is one of its major limitations. Cab indication. Sunflower display. AWS also provides a visual indication in the cab. A yellow and black disk known as the sunflower appears. This remains visible until the train passes the next AWS beacon. It is considered one of the earliest forms of in-cab signaling. AWS operation. Clear signal. When the signal shows green, the electromagnet is energized. It neutralizes the effect of the permanent magnet. No warning is given to the driver. This confirms that the line ahead is clear. Limitations of AWS. Despite its advantages, AWS has limitations. It cannot distinguish between a red, yellow and double yellow. No continuous speed supervision. Relies heavily on driver response. Because of this, AWS alone cannot fully prevent spats. Classification of AWS. Due to these limitations, AWS is classified as a warning system, not a full ATP, a safety aid rather than a complete protection system. It improves awareness but does not guarantee enforcement. Evolution to TPWS. To overcome AWS limitations, the UK introduced the TPWS, Train Protection Warning Systems. TPWS enforces safety by adding overspeed protection, providing better SPAD prevention. This was achieved mainly by modifying beacon configurations. Importance of AWS. AWS was the first large-scale inductive train warning system. It significantly improved railway safety in the UK. More importantly, it laid the foundation for modern train protection technologies. To summarize, AWS is a classic UK-based train warning system. It uses magnetic induction and fail-safe principles. It provides audible and visual warning to the driver. Its limitations led to the development of TPWS. AWS represents an important milestone in railway signaling history. Okay, thank you.